I am going to record this so that there will be a link to this video in Canvas after I get done. So if you didn't quite catch it all, or you want to go back and re-watch it or whatever else, you can go back and see it. And then for anybody who was unable to join us on this tonight, we will have, they'll have access to that as well. So I am going to try and start the share on this and see if I can make this do what I want it to do. Let's see if we can do that now. Well, then I'll just do this differently. Okay. So you're going to get to see my screen right now. So it'll be great. Okay, so we are going to do, we're going to start with section 2.4. This is a little bit more on slope, okay, as we're processing. So the first thing that we're going to talk about is parallel lines. Now, one of the things that happens is parallel lines never cross each other. Okay, that's part of it. Question got asked, is the test still happening next week? Yes. I have a plan in place. The test will take place in class, regular class, so y'all will meet. I'm going to have somebody come proctor that test if I'm not able to come back, okay? My hope and my goal is to be back by then. If I am not, however, I have somebody that will proctor, and I am working on a way to do like a one setup for a Zoom call to where basically I would be zoomed into the classroom and projected on the screen to still be able to do review with y'all for that first 30 minutes, basically, that first 30, 40 minutes that I would normally do, so that would still happen, okay? I'm going to try and make that pretty much as close to I was standing there in that room, and I can relay that whoever it is that's proctoring for me will be able to relay any sort of questions that y'all may have that I can still answer, and then you would just sit and take the test the way you normally would. Again, my hope is to be back before then, but if I cannot, I am working on a contingency plan to make that happen in as regular of a setup as I can, okay? So now, parallel lines never cross each other, okay? Now, inside of the math world for that, it kind of has to happen in two parts. And the first two things of this are going to sound very, very similar, but it depends on what you are given, okay? So the first one says if two non-vertical lines are parallel. So this is, they're telling you line 1 and line 2 are parallel, okay? Like that is a statement of fact that they are telling you, okay? Then they have to have the same slope, okay? Now then, that means when you're looking at your equations, if they're in, say, y equals mx plus b, those m value slopes have to be equivalent, okay? Now, the second one says if two distinct non-vertical lines have the same slope. Okay, this is they give me like a list of equations, and I'm sitting there just looking at y equals 2x plus 3, y equals 4x minus 5, y equals 2x plus 4, whatever it is. And I notice that I've got 2x and 2x. Those match. That means they must be parallel. So it's kind of what am I handed? What do I then know coming out of it? Versus, and those sometimes are different. The first statement is they're telling me, period, point blank, they are parallel. Done. That means the backside of that is the number in front of the x has to match. The revert, or the kind of secondary part of that is if I have a bunch of equations and I see the number in front of the x's match, then those two are parallel. That is the kind of result that I have from it. Then two distinct vertical lines. Now remember, if you remember the picture from last week, our little Bob the skier guy, vertical lines are undefined. They don't have a numeric value, so I can't compare things that aren't defined. So vertical lines, as long as they're not the same one, are parallel by setup, okay? So Oftentimes what they're going to do is they're going to ask you to write the equation of a line that goes through a particular point and is parallel with some other point, okay? And in this one, they want us to do something in point slope. So I'm gonna write something in the screen on my board here real quick, and then I'm gonna see if I can force it to shift over. Okay, so hang on. I'm gonna see if I can make it forced to go over here to this other side. Okay. Okay. Did it now? I'm hoping it now forced the white screen to pop up. Did it make this one come up really big? Did this screen, can someone tell me, did this screen come up really big?
Yeah.
Maybe. I know I've got a glare on my screen right now. Got really bad overhead lighting in here. Okay, so here is the example. Let's see. Let me check one other thing. Hang on, I'm trying to check one other thing.
So is that saying that point minus slope? Or is that just saying that the point slope? I think I'm being retarded. Never mind.
Okay, let me try this again. Okay.
So is the negative 2, 5 what they're going to give us, or that y equals 3x plus 1?
Hang on, Kara. I know you're talking to me. Hang on.
Oh.
Say it again, Kara.
Say it again?
Mm-hmm.
Okay. The negative 2, 5, is that what they're going to give us, or the y equals 3x plus 1, what they're going to, I mean, how'd you get the y? That one.
Okay, so what happened with this one is this is the example. They gave us this point because they want it to be parallel, go through this point. They gave us this equation because we want to be parallel. Okay, so they said through this point, sorry, that is a really bad glare. And then parallel to this point, or parallel to this line. And then this is the form that they wanted in, okay? Now, Danielle, I did not forget about you. I am gonna pull back and show you those two example things that I was had in that last slide.
And I don't know if it's just mine, but it's showing your face, but it's showing your example screen like at the top. I don't know if the video
so that's
is
a little bitty tiny. Okay, let me see if I can. Yeah, that's what let me see if I can force this to do what I want it to.
Yeah, I can't even see the examples. I can only see you.
Okay, let me try one more thing.
Thank you.
Because it was working a second ago, but then I don't know if you pressed something and then it decided to be weird.
Is it doing it better now?
Yes.
You're there. Yeah, that'll be fine.
Did the example come up better now?
Yeah, the example, it's just, yeah.
Okay, so the example's the big one right now, right? My face may be little, but the example's big. Okay, we'll make this work. Okay, so we need that slope. Since they want it to be parallel, okay, we need this slope. Now, point slope form is the one that looks like that. That's our point slope form. Okay, so we have got, that's going to be my M. And that's going to be my X1, Y1. So when we get ready to write our line, and I'll move this down. And then the only cleanup we're going to do is this. Sorry. Keep taking it down.
Is that 2 negative?
Yeah, this one, yeah, sorry. Let me see if I can do it a little bit difficult. There. Yeah, so since this was -2, that -2 went there, and we just cleaned up the minus minus. Okay, now, real quick while I've got it still on here,
Wait, I
those
have
kind
a
of like
question.
3 rule things that just came up off the other page, okay? So, the first one is, if I've got a grid space, there's a line, there's a parallel line. So they're telling me they're parallel, okay? This is like statement of fact. Then whenever I am finally given
Oh.
okay, once they give me these, I'm going to notice those 2 slopes match. Okay, so that's what that first rule said. I'm going to move over just a little bit. It'll still be there for a minute. Okay, now,
Let me
what
see.
the second rule was saying is if I am given y equals 3x plus 1, okay, this one and this one have to be parallel if I were to go put them on a graph. Because again, this and this match. So again, it's what you're given versus what you're told. This one, back over here, they told me parallel lines, but I didn't know these equations yet. Okay? I was told, here we go, parallel lines, period. Okay? If I can figure out what the equations of these lines are, like we've got here, then I'm going to notice that this is, whatever this number is in front of x is going to have to be the same on both of them. That's what guarantees me parallel. The concept here is, if I have to go up 1 over 2 on the green line, then I have to go up 1 over 2 on the red line to make sure that they're always going up and over the same amount. So they continue to not touch. Okay? So told me they were parallel. After the fact, I got their equations and go, oh, look, they happen to match. Okay. Now, second version, or that second rule, and this is the one that said, if they have the same slope, so in this case, I have a 3x and a 3x, not even looking at that green one in the middle. These two lines, so the red one and the black one, okay, so our red line and our black line are going to be parallel because they have to go up and over the same amount for each one. Okay. Now, the green one was just another one in the list that I know it's not parallel to the other ones because it's got a different number in front than this. Now then, the last one, so that part 3 that was on that slide, is if you give me a vertical line and you give me another vertical line, those two lines are going to be parallel to each other. They don't have a slope because remember, Bob fell off the edge of the cliff. His life is undefined, said the undefined word. I can't compare, like on the example, like on either of the other two, I can compare 1/2 to 1/2 and decide, are they the same? I can compare 3 to 2 and decide whether or not they're the same. But with vertical lines, they don't have a slope. So I can't compare numbers that don't exist. So they just stated as a fact, vertical lines are going to be parallel to each other. Hopefully that clears that up. And that was, when I get ready, let me go back to my, there we go. That was for this thing that they were talking about. Okay, this one about the number 1, the non-vertical lines are parallel. So that's, they give me the drawing, and then they say they're parallel. When I get the equations for their lines, slopes will match. The second one was going to kind of give me the list of equations. When I find numbers that match, they are parallel. That's the kind of backside of it. And then the last one is about the parallel line, or the vertical lines being parallel.
I think the only thing I'm confused about is how we would see it like in a word problem, like on our test or something.
Okay, so you're really going to see it more like this example. Okay, the one where they said go through -2, here's a line, go through that line.
Okay, and so like what would be, so
it would pretty much word exactly like this example that's up on the screen right now. The one that says write an equation of a line that's parallel through, passing through -2, 5 and parallel to the line whose equation is y = 3x + 1.
and so we would answer it as in,
You
what
would
draw-
then write the answer. Oop, let me move this back over.
like we wrote it's I can talk today, like we wrote right there.
Yep. So, sorry, I got crap tons of cords. Okay. So then this is the information that came out of there. Your answer would look like this.
Okay. Could you do like a, I'm not sure exactly how you got all of that from there. I don't
How I
know
got
if
to
it's
here?
me just overthinking it. Probably what the case is. Yeah, how you got the x - 5 = 3 and then the through there.
So let's walk. Okay, so this was the point that they gave us, right? Straight out of the example that was on the PowerPoint. This was the line that they gave us. And then this was the format.
Okay.
Okay, so I started by writing point slope form. That's this one. Okay, this is one of the forms that came up in section 2.2, I think. think this one came up in 2 too.
Okay.
Okay. So now, X1 and Y1 for here are just going to be straight out of the point here. So those are going to get replaced with the values. And then my slope for parallel has to be the same as this slope. So that's how I got, that's going to be my M.
Okay,
So then plugging in, I've got just the straight Y. Y1
So
was
the-
5. So I plugged that
so
in.
the M would be what? Is
3. It's going to be this number. That's going to be our M.
Okay.
So then M's 3. Then I have my X. I brought down my minus sign. My X1 is a -2. So put the -2 there. Sorry, I've got the dog over here.
Oh no, it's fine.
And then we want to keep it in this form that looks like this. So the only thing I cleaned up is this negative turns positive.
Okay.
So that's the only thing that we cleaned up.
Okay. I think I get it now. I think I was just missing something for a second there.
That's fine. Okay, so now let me get back into our PowerPoint. Okay. Okay, so the next thing that we're going to look at is perpendicular. Okay, now with perpendicular lines, not only do they cross each other, that's part of it, but they cross each other at a 90-degree angle. Okay, now then, the way that that's going to happen, and mathematicians made it all this big fancy thing that it didn't need to be. Okay, because they want to talk about the products of their slopes is the product of their slopes is -1 and all this crap. Okay, what that basically means, and you may have heard it also called opposite reciprocals. Okay, basically what it says is, in order to be perpendicular, whatever the slope is on one line, you have to flip it and switch its sign. This is what's going to guarantee us to be perpendicular. And I'm going to show you something about that first before we actually get into the example. Okay. Now, the way they word these 3 rules is exactly the same way that they did the parallel. And it's not so much that you've got to know how the rulings work. It's more that you can do them in application. Okay. So if they're perpendicular, the product of their slopes has to be -1. They need to be flipped and switched. And I'm going to show you what that means here. If the product of the 2 slopes is -1, if they're flipped and switched, then they're perpendicular. Then they're going to do a horizontal line, so straight across, and a vertical line up and down are perpendicular, period. Okay? So now, here's what I mean by this. Okay, so if I have the equation and I am making this one up, okay, so if I have something like y equals 3/2 x plus 4. The perpendicular slope is I take this slope, I'm going to flip it over, and I have to switch its signs. So this one was positive, so this one's going to be negative. Okay. So again, the thing that I'm worried about here is the slope. The perpendicular slope is I took that fraction and I flipped it over. And then this one was positive. So that means this slope is going to be negative. Right? Now, let's look at what one of these is going to look like in examples. So I'm going to pull back up the PowerPoint. Okay, so it says find the slope of a line that is perpendicular to the line whose equation is x plus 3y minus 12 equals 0. Okay, I'm going to write that down. All I'm doing is writing it down real quick, and then I'll make the white screen bigger. And we want to go through the point 1, negative 2. Okay. So let me switch. Okay, so here's what we got. We've got, they want us to be the equation x plus 3y minus 12 equals 0, and through the point 1, negative 2. Okay, first thing that's got to happen, I need to get this equation into y equals format. So I'm going to add the 12. I'm going to subtract the x. And then I'm going to divide by 3. I'm moving. The dog insists
Can you run
on
through
being
that one more
part
time,
of
just like saying it out loud?
the journey tonight. Do what, Kara?
Can you just run through that one more time, starting from the x plus 3y, just like saying it out loud?
Yeah.
So I can.
So, started here, I added the 12. I'm still trying to get this thing into y equals, so I need to subtract the x over to the other side. So I just put it, I let the x sit up in the front and the 12 at the back. And then I'm going to divide both sides by 3 so that I can get the y by itself. So our number in front of x is a 1, if they don't give it to us. Okay, so I've got my negative 1 over 3x. Okay, so now this is just what I have to be perpendicular to. So this is the line I got to work with.
I always suck at fractions. So because it's the x is a negative, because it's an x up top, is that why it's a fraction?
Yeah, so they're the number. Let me see if I can get this all fit in here with these tiny little markers. So the number in front of the x is a 1. Okay. I've got to do both this x divided by 3 thing, and I've got to do the 12 divided by 3. So with the x part, I'm going to have to let it sit still in a fraction, because I don't have like a number. It's not like it's 15 or something like that I can actually divide by 3. So I'm just going to have to leave it as a 1 over 3. And then the 12, I can go ahead and divide. Okay, so move over slightly. Wish I had more height out of this, but I don't. Okay. Okay, so perpendicular slope. I've got to take this slope that we just found. I need to flip it over. And I need to switch its signs. This one's negative, so this one's going to be positive.
Excuse me. So we have to put this in y equals mx plus b slope first, and then we do whenever it's like a perpendicular. That's when we're flipping it. So we have to solve it first, and then we're flipping it and doing this to figure out the actual.
Yeah.
Okay.
What happened on that first example that we did was they already gave it to us like y equals 3x plus 1. So they'd already given it to me in y equals format, so I didn't have to go through this stuff that I did over here in blue.
Okay, I got confused because that first one you wrote down, the 3/2 x plus 4, that first one you made up, I thought you switched to a different equation.
Yeah, no. So if they give it to you in y equals format, beautiful. Okay, it's just less work on us. If they don't, we got to get it. So we got to do some blue over here. Then I can actually step into the actual problem that they're wanting us to do. Okay, so this is now my m that I'm going to use. I've still got that x1, y1, that's the ordered pair that they gave us. So now, so we've got y minus our y number, it's -2. Yes, we will clean that up. Okay, we're not going to leave negative and stuff. Slope is 3/1. Guys, 3/1 is 3. Okay, and then we've got x minus our x number. So all I did was clean up that negative.
Okay, so since it's 3/1, we just leave it 3, right?
Mm-hmm. Think about what's 3 divided by 1. Yeah. So if you can make it cleaner, you know, like you have something like 3/1 or 2/4 or something like that, where you could make it a little bit simpler, go ahead and do that. Okay. Now, if they wanted it in point slope, we're done. Okay. If they wanted you to get it into y equals mx plus b, then just finish getting this for y. Oh, sorry. I messed that up bad. I didn't copyright. I'm sorry. That's bad on me. And this would be called slope.
Oh, a brain fart. How'd you get
that got
negative?
really messy. Let me see if I've got a better pen.
That wouldn't be -1.
Let's see if I can use this. Okay, so now you're not going to have to do both of these answers. You're not going to do both the green answer and the black answer. It's going to be dependent upon which format they ask you to do. Okay, so if they ask you to do point slope, that's your green one. If they ask it to be in slope intercept, then you would go ahead and finish working all the way down to the black. Okay. Let's look at our PowerPoint again. So.
Can you go back to it? Oh wait, I still see it. Never mind.
Yeah, I'm not erasing anything. Like I'll leave it over there for just a minute. What you can do inside of Zoom, you may have an option that you might can like click on one of the videos to make it larger. I don't know if it'll let you do that when I'm in screen share. but when it goes back, you might can. And I'll leave that on there for a second until I've got to erase it for the next example. So now then, sometimes they're going to talk about slope as a rate of change. And when they're doing this, they're really talking more of like an application type of idea, okay? That they're going to give you a couple of data points. Now, they may not be directly stated as like X, Y ordered pair data points, but you should be able to figure out a first set and a second set. And they will ask you about how the slope is changing over some sort of time. Now, the other one is called an average rate of change in a function. And for this one, we're going to go back and use function notation to find a couple of values. The concept behind either of these, okay? When my kid was born and they want to see a kid all the stinking time, okay? They want to see him at 1 week old, 2 weeks old, a month old, 6 weeks old, 8 weeks old, 3 months old, 4 months old, 6 months old, 8, 9 months, a year, 15 months, whatever else. And every time we'd go in, they would measure his height and they would measure his weight. And inevitably what would happen is they would tell me something like either he's a little heavy for his age or he's a little short for his age or something like that. But the next time I would go in, they'd go, oh, he's perfectly normal. And I'm like, okay, so you caught him the last time, like right before a growth spurt. So he would like pack on a bunch of weight right before he'd take a growth spurt. And so I'd come in and he'd be heavy and short. And the next time we'd go in, he would have taken his growth spurt and everything would have leveled out. And they would give me the little chart and whatever else that went with it. And it finally boiled down to, they kept going back and forth and back and forth and back and forth. And I finally looked at them and I said, from the time he was born to where he is now, is his average rate of change or is his average growth what you expected it to be? And they said yes. I said, then that's all I care about. Okay, I can sit here and finagle all the little bitty tiny things all I want to. But as long as his average over the long run is what they want, that's what I'm cool with. And that's what we're going to use this formula for. And I will pull that formula back up, okay, when we need it, okay? So we're going to look at the slope as a rate of change. So in 1990, 9 million adult men in the United States lived alone. In 2008, 14.7 million adult men in the United States lived alone. Use this information to find the slope of a linear function representing adult men living alone in the United States. Express it to 2 decimal places and describe. Okay. Let me stop the sharing on that. Okay. Everybody good that I can make the lovely whiteboard go away? For now. Okay. So.
Yes.
Okay, so what we were told. 1990, we had 9 million men. In 2008, we had 14.7 million. Okay. Now, what this kind of feels like is a set of ordered pairs. And so now, what we want to do is we want to use our slope formula. Sorry, let's let it go just a little further. So we've got, ooh, that green does not show up. We've got our first pair and our second pair. So now we're going to have this down. Okay. 14.7 minus 9 is going to be 5.7 over 18. Put that on the calculator. They said 2 decimal places, so that's going to be 0.32.
Can you explain the decimal, what you just said? I got the 5.7 or 18.
Say it one more time, Kara.
What did you mean? I can't see all of it, but 5.7 over 18, right below that, 3. Where'd you get the 0.32? What is that?
I just did the division.
Oh, okay.
Yeah, so that's just the division. Now, the interpretation, this is positive. So it increases 0.32. Now, if you remember, it was talking about millions of men. So I said it increases, and that's because this is positive. Okay. If this had been negative, then I would have put decreases. Okay. The million right here is because they said 9 million and 14.7 million men. Okay. And then our other thing was units of years. So I just put per year. Okay. So I'm going to write the last example. Up here.
Is it still following the perpendicular slope, like note? Hold on. I got separated. Never mind. I'll catch up.
All right. Now, one thing about slope, okay, on this is if we are doing something graphing wise, okay, if we're doing something with a graph, then we're going to prefer our stuff to still be in a fraction format. So if we're going to have to go to we want to have this fraction format because that tells me how I like count up and over and whatever else. If I'm just needing it to describe something, then we kind of get our choice, okay? Now, this one said they wanted 2 decimal places, so that kind of implied that they wanted us to go ahead and do the division and run it into an actual, like, single number, non-fraction type thing, okay? So it kind of depends on which way they want it stated. So this was our number, and then this is, they asked for an interpretation or describe what it represents, and that's what this little sentence statement was down there at the bottom. All right, I'm going to write up the last example so I don't have to flip back to the PowerPoint for it. Okay. So. Sorry, let me get the glare off. Find the average rate of change for f of x equals x cubed from x1 equals -2 to x2 equals 0. Okay, so what we're going to do, you guys can see the setup that I'm doing right here. It is crazy insane. Okay, we're back. Yeah, so here, I'll just let you see my setup. There's that and a whiteboard. And I'm using my phone as a document camera. It's great. This is great. Okay, so what we're going to do with this formula that we have to have okay. Now, y'all, please don't freak out over this. F of x is just the same thing as y. So all we're doing is a fancy gussied up way to say y2 minus y1. That is the exact same thing that we just did with slope. Okay, so that's not changing. Now then, let's talk about how we're going to get some of these values. Red's okay. Okay, so I need to find f of x2. Now, my x2 number is 0. So that means I need to do f of 0. Now that means I'm taking 0 and I'm going to plug it into my equation. So 0 times 0 times 0 is 0. Okay. So now, f of x1, again, my x1 number is -2. That's cubed. I've got a mark in my board. Okay, so -2 times -2 is 4, times -2 is -8. Okay, so now we're going to plug everything in. F of x2 was 0 minus f of x1 was -8 over x2 0 minus x1, which is -2. All right, so we're going to clean that up a little bit. Negative, negative is going to turn positive. Again, I see negative, negative on the bottom. 0 plus 8 is 8. 0 plus 2 is 2. And then we can divide. 8 divided by 2 is 4.
So that 4 is the answer to which equation up top?
Yep. So 4 is the average rate of change.
Average rate of change of the f of x equals x cubed?
Cubed.
Okay.
Okay, for my deaf ears, can you repeat that again? Because
yeah,
that was a little fast. So 4 is the what?
4 is the average rate of change for that f of x equals x cubed. So that is.
Yeah, so Danielle, we're just plugging everything in with the equation at the top, and then at the end, the 4 is the answer to that x cubed.
Okay, now, that's the last thing out of 2, 4. Okay, so now we've got to do 1.4. Sorry, I'm getting an echo, and I'm trying to mitigate the echo. So now we are going to look at section 1.4. Okay. So I'm going to try and do this one. Okay. Now, part of what we've got with this, okay, I have kind of already talked to you guys about. Okay. So, first thing that they ask, come on, okay, is where do imaginary numbers come from? Okay, so I'm going to switch off here real quick. We're going to talk about it. Now, we talked about this briefly when we were talking about functions. And I asked, what is the square root of 25? And y'all told me it was 5 or negative 5. Okay. So now, under that now, even if we had something like square root of 13, which is not a pretty answer, it's still going to be the positive number, whatever it is, and the negative version of that number. Okay, so I'm still going to have 2 answers for that. Now, square root of negative 36. Now here's the problem. The way we did 25 was because 5 times 5 was 25. Negative 5 times negative 5 was 25. The only way you can get this to happen, if you're going to use like whole number type stuff, is if I do a 6 times a negative 6. But that goes against what it means to be a square root. Because square root has to be the same number times itself. Okay? So, here's what mathematicians did. Okay? Now, you are not going to have to show this math every time, but I want to show it to you once so that you understand. I can rewrite 36, negative 36, as negative 1 times 36. Now, one of the things we can do with square roots is you can separate multiplication. Can't do it with addition or subtraction, but you can do it with multiplication. Okay. Now then, this part we handle just like we did up here. Okay? So it's either going to be 6 or -6. We move on with life. This is what mathematicians had problems with. And so they did what any mathematician does. They said, we are going to call I. Okay, now I have a little tail on mine just so you can tell that it's an I and not a 1 or anything like that. The letter I means square root of -1. Okay, so the letter I means the square root of -1. Period. It's like pi is 3.14. The letter I is square root of -1. Period. Okay, which means we could then write this. And I'm just going to do the positive one. But we don't write letters in the front. We put letters in the back. Right? Now, I am by no means saying that you are going to have to write all of that math out every single time. No. If you were given square root of -81, I know I can take the square root of 81, it's 9, and I have a negative under there. So that's going to be 9i. Okay, my point is you don't have to show where you pulled the -1 off and you separated it and all that kind of stuff. You can jump straight from here to here. Okay, so if you know you can take a pretty square root of 81, then do it, it's 9. And then the fact that it's a negative underneath says we're going to have I. Okay. Back over here into our PowerPoint. Okay. Now then, the other thing is, if I is the square root of -1, I squared is -1. Okay? Period. Now, what that means is you will not leave I squared in an answer. And we're going to see that a couple of times coming up, okay? You'll see an I squared show up. It will always be traded into a -1 every single time, okay? Now, when we start to bring in imaginary stuff, okay, this imaginary unit thing, this I thing, we now have a set of numbers called complex numbers. They are in the format A plus BI. A and B are going to be numbers. Any numbers you want them to be. Okay? A is called the real part because it's just a real number. It's just a number. The B or the BI part is called the imaginary part because it has the I on it. Okay? Now then, as long as you have a B part, you have an imaginary or complex number. Those two words are kind of interchangeable. Complex and imaginary. Okay? You're going to hear me call them complex. Okay? But they may also be called imaginary. Now then, if you only have the BI, so like 9i, 6i, those are called pure imaginary. Now, I'm going to write down, here in just a second, I'm going to write down some complex numbers so that you can see what they look like. And then I'm going to write down something that's called a pure imaginary, just so that you can see the difference between the two, okay? So I'll let y'all copy what's on that slide real quick, and I'm going to write down a couple of examples here. And I'll switch it over. Hang on. Let's move on. Okay, so here are, sorry, trying to get the glare out there, some complex numbers. Okay, -3 plus 4i, half minus 3/4 I. Notice it just has the two parts. We have one part that does not have an I on it and one part that does. Okay, it can be numbers, they can be fractions, they can be decimals, they could be square roots, whatever. But if it has both parts, okay, it's a complex number. Now, pure imaginary only has the I part. It doesn't have this extra number up here on the front. So that's the difference between complex and then pure imaginary. It's kind of like having a mutt breed and a pure breed, okay? The pure breed is saying you can only have the imaginary parts. The complex is saying you can have a mix of both. Now then, the next thing that's going to come up, and I'm going to write it over here on my whiteboard, and then I'm going to pull it back up on the slide, okay, so that you'll be able to see it on there as well going into the next part, okay? Is they're talking about equality okay, equality of complex numbers. Sorry. That's really bad glare in here. Okay. It says okay. So it says A plus BI equals C plus DI if and only if A equals C and B equals D. Guys, they're not going to write okay, because that's a does statement. 3 and 3, 4 and 4. It matches. Okay? That's not what they mean they're going to do. What this means is they're going to do something like okay, and guys, do not freak out about this I. Treat it like a letter, like the same way you would an X. If you were given this, you would say combine like parts. That's all they're talking about up here with this, is we're going to combine like parts when this happens. Okay. Now then, I'm going to go ahead and pull the PowerPoint back up. Okay. Bring up this next slide. Okay, so there's that the equality statement. Now, some of y'all are going to have a conniption when this says operations and that looks like alphabet soup. Okay? Please don't. Let me work an example and show you that it truly is going to look and feel like regular numbers and letters, what you've done in the past. Okay? The way it has to be written up makes it look really, really complicated. It's not, I promise. So I'll give y'all a second to get that down.
So the first one you just did with us was the addition, and so the subtraction and multiplication are just the same, pretty much.
Yeah, there's a little bit of change. Subtraction actually works a little better when you see it done in an example than it looks if I try to put it in a whole bunch of letters. Multiplication, I didn't even put down the alphabet soup for that because it is nasty. Okay, like you will get lost in it. Okay, and it's easier because it really does. If you've had even just a little bit of algebra background, it's gonna feel kind of math instinct. Okay, it will feel very follow your gut when we do the examples. Okay, when these come up.
Okay, so you are doing examples of each of the other ones.
Oh, I'm gonna do them all. Sorry, y'all. I'm trying to control this echo. Okay, so if y'all want to go ahead and write down both examples, go ahead. Okay. Let me get the first one. Okay. So now I think I'm going to be able to make this thing. Oh, I keep going the wrong way. Okay. So let me ask this. If that looked like that, if those were X's instead of I's, what would you say to do?
Combine like term.
Combine like terms. Why is it any different if they're I's?
They're not.
It's not. The parentheses here are just there to show you this was a complex number. So I did 5 plus 3 and got 8. Then I've got -2 plus 3 is 1. You could also just write it as 8 plus I. That 1 there is kind of an optional writing. So there's addition. Okay. So now we're going to look at one for subtraction. Okay. So now with subtraction, this one I'm going to need to distribute that negative through that line. We have -12. Minus is going to make plus. And again, we're going to combine like terms. So 2 minus 12 will be -10. And 6i plus an I is 7I. Okay. So it is very much follow a math instinct for that. Okay. Now, we're going to look at a couple of these for multiplication. Okay. And these are going to be the exact ones out of the PowerPoint. We're going to do 2 multiplication ones. Now, your math instinct should tell you that you're distributing that. Okay? So I'm going to have 7I times 2. It's going to be 14I. And then I've got 7I times negative 9I, so that's going to be negative 63I squared. Okay? Because I times I, or a letter times itself, is going to be squared. Now then, way back at the beginning of this PowerPoint, we said we do not leave I squareds in our problem. I squared is negative 1. Okay, and again, that is because I squared equals negative 1. So now I'm going to clean this up. Negative 63 times negative 1. I'm going to turn into plus 63. But they're going to want it in A plus BI. That's the format that they're going to want it in. The 63 is positive, so I keep it positive. The 14I was also positive, so I keep it positive.
Can you move it down just a little, please?
Say it one more time, Kara.
Will you move the screen down just a little bit, please?
Yeah.
Thank you. And we wrote it like that because the I always goes at the end, like the letters always go at the end, correct?
They want it in that A plus BI.
Right.
Okay, so we're going to look at another one. Okay. This is either going to be foil, if that's the way you've done these. Some people do these little like double rainbow looking things. Okay. Whatever your method is for how that has to happen, make it happen. So 5 times 6 is 30. 5 times negative 7, I. It's going to be negative 35I. I've got 4I times 6. And 4i times negative 7i, negative 28i squared. And I did follow the FOIL pattern for that. If you were taught with a different method, use it. Okay, now, step by step, what I'm going to do, we're going to combine like terms. So negative 35 plus 24 is going to be negative 11. Now then, next thing I'm going to do, the I squared needs to go. Clean that up. So negative 28 times the negative 1. And then we're going to finish up by combining these two. So it's going to be 58 minus 11i. Okay, so we're going to go back to our PowerPoint. All right. So there's the two multiplication problems that we did, okay, that we just finished up with. Okay. Now then, before we do division, we got to talk about what are called complex conjugates. Okay. Now, the first thing I need you to know is these right here, up here in the front, are not negatives. They're just dashes. Okay, we had this problem last week. So a complex number has a conjugate. The only thing that changes here is this sign in the middle. You went from a plus to a minus, or a minus to a plus. Okay. Now then, a very unique thing happens when you multiply a complex number times its conjugate. And guys, I'm not going to ask you to memorize what this little trick is, okay? It is honestly easier just to multiply it out and trust the math, okay? So basically what happens, what you do need to know is when you multiply a complex number and its conjugate, all of the i's should go away. There should be no i's left, okay? And so when we get ready to do division, we actually do it with complex conjugates and multiplication. Okay? So I'm going to switch back over. And first thing I'm going to do is I'm just going to show you a couple of examples of like complex numbers and their conjugates. Okay, that's going to be first. And then we're going to do an example with division. Okay, so.
Miss C, did you say whenever you multiply conjugate, the I disappears?
Mm-hmm. And I'm going to show you that.
Okay.
Okay. Okay, so 3 plus 4i is my complex number. The conjugate is 3 minus 4i. The only thing that changes is this plus to the minus. So if I had something like negative 7 minus I, the conjugate is negative 7 plus 2i. Okay, so again, the only thing that's changing is this sign in the middle. Now, I'm going to show you the special thing that happens when you take a complex number and you multiply it with its conjugate. So I'm going to do multiplication again. So I'm going to follow FOIL. So 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is 12i. 4i times negative 4i is negative 16i squared. Now, what I'm going to start doing is combining these two, but those cancel each other out. Now, don't leave I squared. We change that to a negative 1. So it's going to turn that to a plus 16. Which means that's 5. So there's no i's left. Okay? As opposed to that last example that we did, there were still i's. I think we had something like minus 11i or something like that. But when you do a complex number with its conjugate, what should happen is you get this little cancel out thing in the middle, and then your I squared turns into a negative 1. So there's not going to be any i's left in the end of it.
So on the questions, like the test questions, will it specify that it's going to be a conjugate? I mean, that's what we're going to be doing? Or
Yeah,
do we have
it'll either say something like state the conjugate. Okay.
Okay.
The only other thing that'll happen, we're going to use a conjugate when we get ready to do this next example, which is going to be division. Okay. You'll see where it pops up in this division problem. Okay, so here is the division problem that we're going to do. Sorry. Okay, so here's the division problem that we're going to do. Now, we're not actually, this is what's going to sound weird, we're not actually going to divide. The only thing that we are really worried about in this is I don't want to have any i's left down here in the denominator. Okay, so what needs to happen is whatever math I got to do, I don't want any i's down in the bottom. So logic says we just talked about a way to make the i's go away in the bottom. What we're going to do is we're going to multiply by the conjugate of the bottom, but we're doing it on both the top and the bottom. Okay. Now, I may still get i's in the top, and if I do, that's fine. But I can't have any i's in the bottom, okay? So now, I'm going to do the top multiplication first. I'm going to do this in parts. Okay? So what that is, I'm literally taking and doing top times top. Okay? So I'm going to do my same multiplication that we've been doing. So 5 times 4 is 20. 5 times I is 5i. 4i times 4, 16i. 4i times I is 4i squared. Okay. So, do a little combining right here. We can't leave I squared in it. Okay, so that's our top. Now, move over. Now I'm going to do that bottom multiplication. So that's 4 minus I, 4 plus I. Okay. 4 times 4 is going to be 16. 4 times I is 4i. Negative I times 4, negative 4i. Negative I times I is negative I squared. Combining here in the middle first. Plus 4i minus 4i. It's going to cancel. I squared is negative 1. Okay. So now, we got to put our two parts back together. Sorry. Okay, so now, we'll come back up here. Okay, the top of our stuff, after we did our math, okay, we had 16 plus 21i. The bottom, after we got done with all of our math, was 17. Okay. Now then, normally this would be a perfectly acceptable answer, except they're going to want it in A plus BI format. So the same way that we did like our division thing with the lines earlier, you're going to separate this into 16 over 17, and that's going to be your A part, plus, because it's a plus right here, okay? And guys, this is strictly just so that it's in that A plus BI format, okay? All of this is perfectly fine. They're just wanting it pushed out into that specific A plus BI format. Okay. So, going back to our PowerPoint. Okay. So there is, and that's how it would be worded, okay, is divide. Okay. Okay. Now, the next thing, it's actually the last thing we've got for the evening, okay, is what's called the principal square root, okay? Now, basically, the big wording thing on this, all this wording stuff, all it means, okay, is if you see square root of a negative, if you cannot do any other math with it, okay, you can't clean it up, you can't make it look prettier, at a bare minimum, you take the I out, okay? And I know there's kind of some funky notation in here. You're going to see me do this, okay? The very, very first thing you do is if you see square root of like -3, drag an I and put it out in front. That is rule 1, okay? That is what this principal square root says. Pull the I, so notice it has the negative here, drag that as an I out in front. Now, if you can make it prettier, make it prettier. But if you can't, don't, okay? So, what we're going to look at, I'm going to write this first one down, and then we're going to talk about it. Okay. So let me stop the share. Okay. Okay, so this is that first example. Now, the very first thing you do before I deal with anything else, I see a negative under here, I bring it out as an I. Very first thing I do. And I'm going to do the same thing on the other one. Okay, so very first thing that we do there. Okay. Now, from here, we've got to see if there's a way that we can break down the 27. Now, I want to figure out a way to break down 27 where I can get a number that I can take a square root of. Okay, so stuff like 4 or 9 or 16 or something like that. potentially with a number, because I can't take the square root of 27. Okay, if it was like 25, I would have written 5i and been done with it. But I can't. Okay, so one of the ways that 27 will break down is 9 times 30. Okay. Okay. Now, over here on the 48, there are several ways to break down 48. Okay, but I'm looking specifically for a number that I can take a square root of. Okay, so thinking through my squares, I can do 16. Okay, now the process that I'm following for this, okay, is called simplifying square roots. Okay, so if you're not super duper comfortable, okay, or kind of going, I'm not real sure how she decided what numbers to there, look up how to simplify square roots. Okay, and that will help kind of guide you through this process. Okay, so now I can take the square root of 9. The square root of 9 is 3. So that's going to come out. This 3 is this 3 that was the plain one up here. Okay. Now, over here on this other one, I can take the square root of 16. That's 4. I think you can see that over here just a little bit better. This one had a bunch of 3s in it, so it wasn't as clear, but this one is. Now, this next step, the only reason I can do this is because this I square roots of 3 matches this I square roots of 3. Okay, that's the only reason I'm going to do this, because this almost feels like 3x. That whole thing is like an x plus a 4x. Okay, that's what this is fixing to feel like. So this is now going to be 7. 3 plus 4 is 7. And then it's this whole back piece. Okay. It's that whole back piece like that. Now then, just for sake of reference, let's say you had gotten something like okay, let's say you had worked a problem down and you had something like this. You cannot combine these up because this is I square roots of 3. That's I square roots of 7. They don't match. That means this would stay exactly like that.
So if the square roots are that do not match, like the 3 and 7, you can't do anything further with it because you can't break it down?
Nope, you got to leave it the way it is. So we're going to do one more example. Let's move back up here. So this is the last example that we've got. Okay. Now, first thing I'm going to do, I see a square root of a negative. So I make it an I, square root of 3, and I've still got the square root of 3. So again, the only thing I'm doing is I see square root of a negative. I drag that out in front as an I. Now, the next thing I'm going to do is I'm going to handle this squared thing. When you square something, it means you multiply it times itself. Okay, so now we're going to do the same type of multiplication that we did before. Okay, so negative 2 times negative 2 is going to be 4.
Can you move it down just a little, please?
Negative 2 times negative I. Okay, so negative times negative is positive. 2I square root 3. So I'll do my inners. So negative times negative is going to be positive again. 2 times an I, square roots of 3. And then this last one will be kind of funky. So I've got negative times negative is positive. Got that. I times I is I squared. Okay. Square root of 3 squared. Because I've got square root of 3 times square root of 3. Okay. Now, first thing I'm going to do, I'm going to combine these two. I'm going to deal with this back here in just a second, okay? Okay, these match exactly in the back. I squared to 3, I squared to 3. Okay, so now we're going to deal with this lovely little monster back here at the back. Okay, now then, square root and square cancel each other off. So that's just going to leave me with that 3. So now I'm going to have I squared is negative 1. This is a 3. Okay.
So is that
Yeah.
the canceled out square root 3 and the squared? It's the same thing, isn't it?
Say it again here.
Where you canceled out this square root and then the squared look like it's the same thing, right? Like that's how you can look at it.
Yeah, they undo each other. It's kind of like doing add 3, subtract 3.
Okay.
They cancel, so I'm left with just this little 3 on the inside.
Okay.
So now I've got negative 1 times 3. And then we'll do the last little bit of combining here. I can put together the 4 and the minus 3. And that's going to be our final answer. Okay. Now then, that is the end of 1-4. Okay. The homework sections for 2-4 and 1-4 will open up tonight. I'm also going to open up a review. Okay, and I'm gonna make a comment or an announcement over in Canvas about this. Okay. The review is not for a grade. Okay, it is not. Because here, let me see if it'll bring me back up as the main thing here. Okay. The review is not for a grade. Okay. The review is going to be, number one, it's beefy. It's like 100-something questions. I'm not fixing to ask you to do 100-some-odd questions on top of whatever homework you've already done. Okay, not going to ask for it. The purpose of the review is that for the early on stuff, okay, the things like 1.7 or 2.1 or any of that super early stuff that may not still be open. If you're like, man, I really wish I could practice that or see it one more time or run through it again before the test, you can go find that stuff in the review, okay? So you can do 1 review question, you can do 20 review questions. It doesn't matter, okay, because it's not for a grade. It's there for you to be able to work through problems that you want to go through, but it not affect or impact your homework average. Because I know some of y'all work really super hard and you put a lot of time into getting that homework average up, you know, and high and worked out and all that kind of stuff. And you're like, I don't want to go like do a similar problem and mess that up and bring my homework average down. So the review is there to help out with having access to problems that we have done in class or the type of problems that we have done in class and it not affect your homework average. Now, it's going to look like a homework assignment, okay? It's going to be housed over in the homework sections, and it is not for a grade, okay? That's what I need you to understand, is that it is not for a grade. Now, again, while it's open, it may look like it's grading, okay? Because it will tell you that you've got, yes, it will show the correct, it should show you the correct answer. It acts and behaves just like a homework assignment. So it'll show you, it has all the same helps. You can do help me solve this, ask my instructor, show me an example, all that kind of stuff. The only thing it doesn't do is count for any sort of additional into your grade type of thing. And I did that because I didn't want it to like drag your grade down, and I wasn't going to ask you to do another 100-something questions on top of the regular homework. Okay, so that's what I'm saying. You can do 1 problem. You don't have to do any of the problems. You can do 50 problems or any quantity of it that you like. You can jump around. Okay, so if you like, hey, I need to see one of those questions out of section 1.7, and that was like question number 2, and then you skip over and like the next one you do is question 35, fine. Okay, because again, it's not for grade. You can go in and click and do whichever problems you feel like you need to practice on. Okay, if you're like, nope, I'm good with that, move on. Okay, like I said, it is just kind of a hodgepodge pulled together just of everything that we've covered in this stuff. Yes, Danielle, it will be posted as soon as I finalize the video. I'm going to upload it onto YouTube, and I will put a YouTube link in Canvas, so it'll be under the announcements. So yes, there will be it'll get posted into Canvas for a link so you can rewatch this. So the review is not for a grade, but you will still have your 2-4 and 1-4 sections that you need to work on for assignments for that. Okay, Like I said, I'm still hoping to be back next week. But if that doesn't happen, I've got a plan in place to do something kind of like this Zoom session for that review time, so that you can still have kind of that rundown. The person who's there would be able to relay questions to me, to be able to answer them during that same review time, kind of pretty much the exact same way that this stuff would happen normally. And then you guys would take your test, and that's if I'm not there. Okay, if I am, I'll run it the way that I normally would. So with that being said, I'm done for the evening. I hope you guys have a good rest of your night. Okay, and if you've got any questions, feel free to email me. Okay.
Bye. Thank you.
Welcome.
Thank you.